The YByte Python programming course available at www.ybyte.in is totally unique because we learn programming by building activities that are fun, and then we think of how we can enhance these activities to learn even more from them. For example, one such activity is the missing operators project. Here, our player is asked a number. For example, let's say I give a number 12. It asks me another number. I say, for example, 34. And then it asks me a question. 12-34 is 408. The answer could be plus, minus, or multiply. Obviously, in this case, the answer is multiply. Now, we have seen the development of this before, so I'm not going to get into this right now. However, let's say our player tries to act smart, and instead of giving a number, for example, here it says, please give me a number. Instead of giving a number, it gives an input which cannot be converted to a number. For example, ABC or any string. Now, when I do this, unfortunately, my program crashes, but that's not really a good thing because my program seems quite vulnerable to let's say, a wrong input from the user side. How can I make my program a little bit more robust? For example, let's say in my enhanced version here, where when I ask a number and I say, for example, ABC, the program determines that this is an invalid input and in fact insists that please give me a correct number. Now I try it again. Let's say I say DEF. Again, the program determines this is an invalid input. Please give me a number. Until I get the right answer, the program doesn't move forward. Now notice, not only the program does not crash, it in fact ensures that the user behaves in the way the user is expected to behave. How do we do this? Let's see this in this video. This will be an enhancement for the missing operators project. The whole idea really is to use this try and except statements. So the try and except statements work this way. We basically tell the interpreter to try implementing a piece of code. For example, in this case, convert to take a user input, convert that to an integer. If there's no error, nothing changes. It just keeps moving. However, if there's an error, instead of crashing, it goes and implements what was in the except part. For example, we can tell the player that there's been some error. Please check it again. Before I move forward, I want you to notice how similar the indentations are to the if-else statement. Remember, the if-else statement also is if condition colon an indentation here, and then the code and else colon an indentation. So in the same way, we have try and except with these indentations. Let's see how we can implement this in our project. Remember, the existing code is very simple. We just say, input, please enter a number, and then we get for the next number. Now, I'm going to just do this for the first number. Basically, what I'm going to say is that, look, try to convert this number to an integer. So basically, I say try again with an indentation. I say, look, input a number, and notice this whole thing is inside try, which means that the interpreter is going to try to do this. If it succeeds, well and good. If it does not succeed, it will not crash. In fact, it will go inside this except and say, well, that's an invalid input. Let's see how this works out in a real code. So I go back to my project here. Remember, this is how my code looked. Now I'm just going to say, let me just put this inside the try and except statement. Remember, try colon, and now I must go and indent this line. And I'm going to say except, for example, and I just say, for example, print that was an invalid input. Now, if I did this, we can try this now. If I just did this much, my program will not crash. If I say, for example, gave it XYZ. Now, clearly, XYZ cannot be converted to an integer. So that is a problematic input. However, my program does not crash. It moves on telling that was an invalid input, asks for the next number. However, it doesn't make sense to move forward from this point here because later on, I'm going to run into problem. So the right thing for me to do would be to force at this point a situation where the user must give me an integer before I can move forward. And how do I do that? Well, I can further go and build a while loop on top of this. So remember, this is my code right now, try and except. I can put this inside a while loop. Now, while loop basically is a loop that keeps working until a certain condition is true. So I define a Boolean variable called say done. I assign it to false, and I say while not done, keep doing this. The important bit is that the moment I get a valid input, which means this statement runs, I just go and set my done to true so that this while loop exits. Now I'm going to do this for one number, but clearly you can do it for any number of times that you ask for a user input. That will make your program very, very robust. So let's just see this working. So like I said, I can just define, I can define a number. Let's say I can define a Boolean variable called done. Sorry, I'm going to call it false to start with. Now, Boolean variables are either true or false. And I say while, for example, not done. Again, I must indent this whole thing now because I need the indentation for the while loop. So I come in here, I just indent this entire thing. Remember, if I get the right input, I must go and set this done to true, because if I do not do this, then my program will be stuck in an infinite loop. It will keep on asking numbers even if I get a valid input. So let's see this working now. Let's say it says give me a number. I go and say, for example, ABC. Now clearly that's not a number. I say, I detect that. I said that was an invalid input. I say, please give me a number. That's because remember when this did not work, it went and implemented the code in the except part and the done was still false. So this while loop continues to run. I try to act smart again. I say XYZ. It figures this out again. That was an invalid input. Give me a number. I finally give up and say, okay, all right, take 34. That is a number and my code moves on. Notice the while loop has now exited because now I'm asking the next question. Now, clearly for your projects, you can actually do this for the first number as well as the second number. That will mean two while loops. But remember, in between those two, you must set done to false once again, because at the end of this loop, done has become true, and which is why the while loop has in fact exited. I hope this was clear to you. Enhancing projects like this, once you've built the basics, is always a good idea. And if you think this is a good way to learn programming through these activities, do look at our website www.ybyte.in, because there are many, many, many such activities and many such ideas that you can learn from. Take care, enjoy programming.